Okay, so today's lesson is going to be on earthquakes. So let's start with the definition of what an earthquake is. So the question we have here is, what is an earthquake? The answer, the correct definition of an earthquake is a series of vibrations induced in the Earth's crust by the abrupt rupture and rebound of rocks in which elastic strain has been slowly accumulating. So let's think of it as a rubber band. Like you keep pulling and pulling and pulling and pulling until it snaps. So here we have the Earth, and there are 4 layers. We have the rocky crust, which is the outer layer. We have the outer mantle, which is the layer right underneath the rocky crust. We have the inner mantle below that, and then the Earth's core in the center. So here we have a little diagram that shows the focus of where the earthquake starts over here. And it works its way out towards the epicenter, and then the earthquake is caused. So now that you guys have a definition and understanding of what an earthquake is, we're going to explore it a little further and see everything that goes into making it happen. Okay. So let's start off with defining what the crust is. Okay, so crust is where the earthquake I'm just going to abbreviate, mostly occurs. Then the epicenter so all earthquakes have an epicenter. Again, I'm just going to abbreviate, but I want you guys to actually write it out. So now you have that. So now let's see, does anybody know what the tool is that is used to measure an earthquake? Okay, we call it a Richter scale. So it's exactly that. It measures how large the earthquake is. So now it ranges from 1.0 being the lowest to 9.0 being the highest on the scale. Okay, another thing that you guys need to know is plates. So let's say here's the Earth surface. Under here, we have these plates. What they do is they move back and forth past each other, sliding. So let me just read something to you, and then we'll try to break it down. There are about 20 plates along the surface of the Earth that always and slowly move past each other. When the plates squeeze or stretch, huge rocks form at the ridges, and the rocks shift with great force, causing an earthquake. So, let's say here's one plate, here's another plate. If there's no room here and they collide, it will cause an earthquake. Okay, let's continue. So basically the way that the book describes it is, imagine when you hold a pencil horizontally, and you push and you push and you push and you keep putting pressure on both ends. Eventually what's going to happen to that pencil? It's going to snap from the pressure on both ends. Same thing with the plates, it's no different. So eventually the more pressure that's applied on each end of the plate causes it the stress in the middle and causes it to snap. Sorry, that's the middle. Okay. So just copy that down. Okay. So now we're going to talk about what a fault is. Okay, so now let's talk about what a fault is. No, we're not talking about his fault, her fault. We're talking about the stressor. So a fault, the proper definition is an area of stress in the earth where broken rocks slide past each other causing a crack in the Earth's surface. Alright, so for you visual kids out there, let's say here's your Earth's crust. Okay, let's just pretend like, let's say this is like a street, a highway. So basically this just splits open. So something else with that has to do with plate tectonics. So I'm just going to read this out and then we'll just write out like the main points. So plate tectonics are basically continents drifting from one place to place, breaking apart, colliding, and grinding against each other. So the theory is supported by a wide range of evidence that considers the Earth's crust and upper mantle to be composed of several large, thin, relatively rigid plates that move relative to one another. The plates are all moving in different directions and at a different speed. Sometimes the plates crash together, pull apart, or sideswipe each other. When this happens, it commonly results in an earthquake. So let's see, how can we best describe this? So let's write so it's plates colliding and grinding against each other. Oh, sorry. Colliding, grinding, breaking apart. Okay, and then let's write, since they move in different directions, okay, they move in different speeds. Which result in an earthquake. So now that we learned about plate tectonics and you guys have an idea of how they work and what they do and what a fault is and where it breaks off, we are going to go a little further with this. Okay. Okay, so now let's just get a few more definitions in. So let's do plate boundaries. So this is where two plates meet. Then we have divergent boundaries. And that's where plates are coming apart. And then last but not least is convergent. Boundaries. And that's where plates crash or crunch together. Okay, you will be expected to know each and every one of these. You need to be able to identify them and define them. So please note them, pay attention to it, understand it. If you don't, keep rereading it over until you get it. It is very important that you know what the different boundaries do. Now we're going to talk about what a seismograph is. So guys, please copy along. It's an instrument used for recording the intensity and duration of an earthquake. Okay, this is not to be confused for a Richter scale. A Richter scale measures how big the earthquake is. So between a 1.0 to 9.0. A seismograph is an instrument used to record the intensity. So the Richter scale measures, the seismograph records the intensity and duration of an earthquake. Please do not confuse these two. It will be on your exam. So let me just read this brief little description so you guys can get a better understanding. A seismograph comes in handy for locating earthquakes as well as being able to see the P and S waves. So right there we have P waves and we have S waves. So let's see what they each do. So you learned already in yesterday's lesson how P and S waves each shake the ground in different ways as they travel through it. So if you guys forgot, you can look back later on your notes from yesterday's lesson and touch on that. Make sure you understood it. P waves are also faster than S waves, and this fact is what allows us to tell where an earthquake is. So P waves, let's just make notes, faster. S waves are slower. So this in the book compares it to P and S waves to lightning and thunder. Light travels faster than sound, so during thunderstorms you will see the lightning and then you will hear the thunder. If you are close to the lightning, the thunder will boom right after the lightning. But if you are far away from the lightning, you can count several seconds before you hear the thunder. The further you are from the storm, the longer it will take between the lightning and the thunder. So let's see, they're basically referencing to P waves as lightning because they're faster. And so let's just do this. I put lightning, sorry. Let's just put faster, comma, lightning. And then slower, we'll do thunder. So basically this comes first, this comes second. So then it says the P waves travel faster and shake the ground where you were first, and the S waves follow and shake the ground also. If you are close to the earthquake, the P and S waves will continue one right after the other, but if you are far away, there will be time in between the two. So like, let's say we're in San Francisco, and we're close to where like the epicenter of the earthquake happens, you would feel them boom, 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 back to back. But if you're further away from the actual earthquake, then you're going to sense that time in between. It's not going to be a back-to-back hit. So please make notes of all this. It's important. I want you guys to be able to define it. And when you see what a seismograph instrument is, which I will give the handout later, you'll be able to define it by just watching the picture, seeing the picture. Now we are going to talk about the San Andreas Fault. Let me just switch colors real quick. Okay. Now we're going to speak about the San Andreas Fault. So it is defined as the sliding boundary between the Pacific plate and the North American plate. So just so you get a sense, what it slices California in two. Okay, so basically, it slices California in two from Cape Mendocino to the Mexican border. So here we see is the San Andreas Fault. You have San Francisco, Hollister, San Bernardino, but there is stuff in between.
Mommy, we're talking.
Okay, so the way our book describes it is the San Andreas Fault is a transform fault. Imagine placing two slices of pizza on a table and sliding them past one another where they touch along a common straight edge. Bits of pepperoni from one side crumble across the boundary onto the anchovy side. The same thing happens with the faults, and the geology and landforms along the mighty rift are extremely complicated. So just like this, let's say this is just your two slices of pizza. This is the anchovy slice, this is your pepperoni slice. If you keep sliding and shifting and it moves quick enough, one will eventually spill onto the other. So, I mean, it's a great example that they give you in a book. So, let's do a little, let's go back to our fun fact. It's not really fun, it's about earthquakes, but you guys know what I mean. The biggest earthquake that, I don't know if it was like the biggest earthquake recorded, but a major earthquake that took place was one in San Francisco. You guys know where San Francisco is located? Very good. California. And California is on the west coast. So it had a magnitude of a 7.8. And how do they measure the magnitude? Using a what? Correct. A Richter scale. Because we said a Richter scale measures the earthquake and a seismograph records it. And this earthquake took place in April 18th, 1906. So that was a very long time ago. So let's just see what it says about it in the newspaper article. It says the earthquake and resulting fires caused an estimated 3,000 deaths and 524 million in property loss. So 3,000 in deaths and 524 million in property damage. That is a lot. It says damage in San Francisco was resulting only from the earthquake. It was estimated at, damage in San Francisco resulting only from the earthquake was estimated at 20 million. Outside the city, it was estimated at 4 million. The sensible duration of the shaking in San Francisco was about 1 minute. So 1 minute, all this happened in a minute. That is insane. So let's talk about another little fun fact, and we will do this in tomorrow's lesson. We'll go further into it. What's a tsunami? And we'll leave it off here for today. Anybody want to guess? Okay. So tsunami is a large ocean wave usually caused by an underwater earthquake. So for those of you that just thought earthquakes happen on the ground, no, they happen underneath the ocean as well. So what it does is, once that happens, it disrupts the ocean, and then these large 20-foot, approximately 20-foot high waves happen. They literally wipe everything out. So basically with a typical wave, water flows in circles. Let's see if I can, I'm sure you've seen them like this, like when it rolls at the beach and then, okay. With the tsunami, the water flows straight. So basically, it just comes up and then just crashes. So imagine it builds all this force, and then it just crashes down. But again, like I said, we'll touch on waves and water and ocean on tomorrow's lesson. So for homework, I actually want you guys to go home, get on a computer. For those of you that have one at home, for those of you that don't, you can do it tomorrow during class as free time. And I want you to find an article on an earthquake and just write a brief summary on how big the magnitude was and how much the damages were, and bring it to class, handwritten, 1 page, and we'll discuss everything in class.